looking at half-life. Well, we talked about how we have isotopes, same element, different numbers of neutrons. Question? Same element, different numbers of neutrons. See if phones put up for me. Same element, different numbers of neutrons. Well, we talked about when the proton number and the neutron number gets too far off, that element becomes unstable. We call that unstable element radioactive. So you should be filling your notes right now. You'll find the, go past the ions one. We're going to come back to that lesson. That's the lesson that has the lab. Since we're having issues with the safety agreement, we'll come back to that. So find the one with half-life. Just look for this slide here. I'm going to go around, make sure we're all there. So here's the story. These elements, they're radioactive, they decay into more stable elements. So we have something called a half-life. The half-life is the time it takes for half, hence the name half-life, for half of those radioactive atoms to decay into a more stable atom. Okay? So if we look at this graph here, you would have, let's say, 10 grams. And this is saying cobalt-60. Cobalt-60 would be a cobalt atom with, what about the cobalt atom? What would CO60 mean? Cobalt-60 is a cobalt atom with what? With 60 what? Not 60 neutrons, no? Not protons. Not electrons. Neutrons and protons, otherwise called the, not the atomic number, it's the number of protons. The atomic mass, the mass number. So CO60, that's a cobalt with a mass of 60. So the half-life of cobalt-60 is the time it takes for half of your 10 grams to decay. What's half of 10? 5 to decay to 5. So my half-life would be, time is on the x-axis. It would be, notice here, that's where one half-life's at. And they tell us here one half-life is 5.27 years. Now, the half-life depends on the element. Not every element has the same half-life. So, you know, if you had carbon-14 would have a different half-life. Every element has its own half-life. So how long would it take for 5 grams of carbon to then decay into 2.5 grams of carbon? We now have 5 grams of cobalt-60. How long would it take for that 5 grams to then turn into 2.5 grams? It would take 5.27 years because that's the half-life. How long would it take for 2.5 grams of cobalt-60 to decay to 1.25 grams of cobalt-60? 5.27 years. How long would it take for 1.25 grams of cobalt-60 to decay into 0.625 grams? 5.27 years. In other words, the half-life is always the same no matter the starting amount. So if you start with a lot of cobalt-60, a little cobalt-60, the time it takes for it to be cut in half is always going to be the same. 5.27 years for this specific element. All right, moving on. Here's another graph showing you a lot of the same things here, but just trying to help you like better picture what's happening. So if we look over here, you have your carbon atoms. Here are stable isotopes of carbon, carbon-12, carbon-13. These elements, the proton to neutron ratio is stable. This atom is not going to want to be, is not radioactive. Now, once you get to carbon-14, carbon-14 is unstable. So it's going to undergo radioactive decay, and it's going to decay into a more stable atom. In this case, it's going to be nitrogen-14. Don't worry about knowing why it's nitrogen-14. We'll talk about that later. Just know that this is the more stable form. This is the less stable form. And then you could think of this much as like grams amount of that radioactive thing, but percentage amounts. Meaning if I have 100% of my radioactive carbon-14, after one half-life, what percent would I have left? Say it again. Start with 100% of radioactive carbon-14. After one half-life, how much do I have left? 50%, right? Because it's cut in half. What percentage of nitrogen-14 do I now have? So after one half-life, I have 50% of carbon-14. What percent of nitrogen-14 do I have though? What was it, Tar? Sorry. 50, yeah, good, 50%. In other words, all of the carbon-14 turns into the more stable nitrogen-14. Okay, after 3 half-lives, how much carbon-14, how much nitrogen-14 would I have? I've done 3 half-lives, how much carbon-14, what percent of carbon-14 would I have? 12.5, good. You would do, because to get to 3 half-lives, you divide 100 by 2, 1, 2, 3 times. So now we're at 12.5% of carbon-14. What percentage of nitrogen-14 would you have left? Or do we now have? How much nitrogen-14 do we make? Not 12.5, it's carbon-14. We make 12.5 carbon-14. Carbon-14 turns into nitrogen-14. Not 25.
It's, I know it's 100, no, it's not 100.
77, not 77.5. 8, you're close. Add 10 to 87.5. What do you notice about these two numbers? They add up to 100, right? All of the carbon-14 turns into nitrogen-14. Or another way of saying it is all the nitrogen-14 comes from carbon-14 decaying into nitrogen-14. Okay? All right, let's keep moving on with it. These are the kinds of problems you'll see on the formative and then like on a feature test. Now, this is kind of what's hard with doing these problems is there is a specific half-life formula you can use. I don't teach it to you because it involves like exponents and logarithms and stuff, and students have a hard time with it. So these are more problems you have to like reason through. In other words, you don't have, when you're solving these, this is kind of my best attempt to get you to organize your knowledge. Let's read the problem. They ask us, what is the half-life of a substance if 18.75 grams are left of a 300-gram sample after 20 days? So what you want to do is fill in the information you do know. Okay? What is my starting amount? 300 grams. Okay, so let's fill that in. What is the time elapsed? 20 days, good. What am I ending with? 18.75, good. So then, whenever you're doing these, there will always be one of these 4 boxes up here. One of them will always be blank. That'll be your X that we have to solve for. Now, there is a formula, if you're into formulas, that you can use here. Half-life equals time elapsed divided by the number of half-lives. So we can solve for our half-life using this formula. So half-life, we'll call it HF, equals, what's my time elapsed? 20 days, okay. Divided by the number of half-lives, which is my, oh, that's a good question. How many half-lives? You don't have it up there. How many half-lives are we going through? This is the length of one half-life. Yeah. 4. Yes. Well, yes. It should be 4. Here's how you would know. You're like, genius. This is what this is for. to find the number of half-lives, you need to ask yourself, how many times do I divide my starting amount by 2, that's a half-life, to get to your final amount? Meaning, if I do 1 half-life, 300 divided by 2 is 150 grams. At the end of 1 half-life, I have 150 grams. At the end of 2 half-lives, how many grams do I have? 75 grams, good. Okay, but we're still not at our final amount, so we got to keep going. At the end of 3 half-lives, how much will we have? 37.5. Okay, closer, but still not there. If you do a 4th half-life, you would have your final amount, the 18.75 grams. Because a half-life is the time it takes to cut the sample in half. Yeah, make sure that you make that connection. Half, that's why we're dividing by 2. So we had to divide 300 by 2 4 times. So number of half-lives here is 4. So therefore, we're going to divide by 4. Okay? So the length for 1 half-life then, which is that's our x, call this x if you want, x would equal 5 days. Every 5 days, that'd be your answer. Every 5 days, we would divide that 300 gram sample in half. Or another way of saying it is every 5 days, that radioactive sample will be cut in half into something more solid.
What's the difference between the half-life that you're trying to find and like the number of half-lives?
The half-life you're trying to find, that's the time for 1 half-life.
So it takes more time for 1 half-life than it does for 4?
No, the 1 half-life just takes 5 days. 4 half-lives would take 20 days. That maybe I could add it here. Like 5 days go by now, we do the first half-life. 10 days go by, we've done the second half. Yeah. Yeah, question.
If it's given that it's 20 days and we can break it down and assume that there's 4 months to have we just
Yeah. If you're a little confused, we're going to do some more of these problems. You don't have to solve these problems the way I did, but this is kind of the best way I can find to get you organized for now. And then I think you'll start to find you can do some of these in your head. You can start to really reason through these. All right, so hang with me. Let's do another problem. So basically, those keep changing what they give you or don't give you. So here they tell us that the final amount left of a 200 gram sample of a radioactive isotope after 30 days, or what is the final amount, if it has a half-life of 10 days. So let's fill in what we know and then solve for what we don't know. What is our starting amount? 200 grams, right? So let's get that down. What is our final amount? We don't know, right? So this is our x, is what we're solving for. How much time has gone by? 30 days, okay. What is the time for 1 half-life? 10 days. So stop here and just use common sense. Just try to picture what is happening. What is happening is you have some amount of 200 grams of radioactive element. Every 10 days, that radioactive element will be cut in half. So days go by, and after 10 days, we'd have how much? Start with 200 grams. 10 days have gone by, so we're going to cut it in half. How much do we have? You'd have 100 grams, right? Now, to find out the final amount, what you need to ask yourself is, well, how many half-lives am I doing? How many times will I keep dividing 200 by 2? How could we figure that out? How could we figure out the number of half-lives we do? Yeah, go ahead.
Wait, well, time elapsed. So, what's time elapsed again?
That's how much time has gone by. So 30 days has gone by. Yes, sir.
You do time elapsed over half-life.
Yeah, good. Time elapsed. So to find out how much time has gone by, you would do how much time to find out the final amount. You would need to figure out how many half-lives you do. So if you have 30 days and you know every 10 days you do a half-life, then you have done 3 half-lives, or you will do 3 half-lives. You have enough time to do 3 half-lives. Okay? Think of it like track. If you have 30 minutes and every 10 minutes you run a lap around the track because you're really slow, how many laps can you do on the track?
3.
You can do 3, right? So what we got to do is we need to do 200 divided by 2, 1, 2, 3 times. We already did it once and we got 100 grams, so let's do it 2 more times. So if we do a second half-life, we would get 50, and then getting to our final answer, if you do a third half-life, what would we get for our final answer? You get 25, right? 25 grams, that would be your answer. That would be your X. Your final amount. Okay? So these problems, again, you can think through these. These are almost more like kind of logic type problems. I promise you can get yourself there. If you're a little confused on it, just keep staring at the problem. Maybe once I'm done doing the notes until it starts to click. Or we'll do a couple more, and hopefully you'll start getting the rhythm with it. All right, they tell us the final amount left of a 350 gram sample of some kind of radioactive isotope after 15 days. Or no, sorry. What is the final amount left of a 350 gram sample of radioactive after 15 days if the half-life is 5 days? So what is my starting amount? 350, okay. What is my final amount? We don't know, so another problem where we don't know the final amount. What's my time elapsed? 15 days, right? And then what's the time for one half-life? 5 days, okay? So to find our final amount, you have to know how many half-lives can I do in 15 days? It would be 3, right? If every 5 days I can do 1 half-life, in 15 days I could do 3 half-lives. That's what I'm saying. You could probably do that in your head, or you could think of it this way. 15 days, every 5 days you do a half-life. 15 divided by 5 would be 3. So to find our final amount, we want to divide our starting amount by 2 3 times. So let's do that the first time. 350 grams divided by 2. After 1 half-life, I get 175, right? Then if I were to do a second half-life, how much would I have? It's a tough one. 87 point, yeah, that's not right. 87.5, okay, almost there. Gotta do 1 more half-life. So after 3 half-lives, what we have? I heard it back there. 42.75. 43. Yeah, 43. 43.75 grams. So that would be your answer. That would be your final amount. Okay? And this should make sense to you. You should be able to visualize this problem. Visualize what's happening. In other words, some students try to memorize how to do these problems. You don't memorize these problems. Reason through it. Just kind of stay calm and think through what do you have, what do you not have, and how would you find what you don't have. Okay? I think I have 1, 2 more.
1 more.
1 more? All right, let's do 1 more. So they're asking us for the half-life. If 8.6 grams are left of a 275 gram sample after 50 days. So what is my starting amount? 275, agreed. What is our final amount? 8.6 grams. Okay. How much time has gone by? 50 days, good. And then what is our half-life? You don't know, it's our unknown, right? All right, cool. So, to find our half-life, what you want to ask yourself is, how many half-lives did I have to do to go from 275 to 8.6 grams? Or another way of saying it is, how many times do I need to divide 275 by 2 to get to 8.6? So if you missed some work on the last question, just go to the previous slide and I have it all worked out for you. Okay. I don't. That's just kind of a rhetorical question. Let's just work it out, right? So let's just start doing it. 275 divided by 2. That would give us 137.5. Am I right? Okay. 137.5. Okay. Well, let's do a second half-life. Oh boy. 62.5? 68.75? 68.75. Okay. We're not there yet, so let's do a third. After 3, my brain starts to break and we get to what? 34.375? Okay. Cool. So let's go to another one, not there yet. So we're doing a fourth half-life. After 4, what do we get to? 17.1875. Almost there. If we then do a fifth half-life, we get to the 8.6. Awesome. And at some point, you can just round it. But this would then get us to the 8.6. Now, that's not your answer, right? So understand what we figured out. We figured out that we can do 5 half-lives in 50 days. So I can do 5 half-lives in a matter of 50 days. So how much time would it take me to do 1 half-life? 10 days. Okay. So you can solve for x now by if you multiply both sides by x. You would get, we rewrite this as 5x. These x's cancel. Equals 50 days. Divide both sides by 5. And you would get 50 divided by 5 is 10. 1 half-life is 10 days. So 10 days would be your answer here. So, as I said, not an exact formula on how to do these. You just got to reason through them and solve for what you don't know. Brings us to the end of the notes. So then if you go to the formative, I assigned you some half-life practice problems. Be going around if you need help. Remember to, you're not using your phone for a calculator. If you don't have a calculator yet, just use Desmos.